Hello, welcome back to another video. Let's start with a joke. What did the fish say when he ran into a wall? Nothing is a fish. All right, so first one in a new topic. So we are now in the topic of, let's go, hopefully, here we go. Numbers and surds. So numbers and surds, we're basically going to talk about irrational and rational numbers. So the first one is we're talking about whole numbers, integers, and rationals. Okay, so basically whole numbers and integers, that's probably what we're most familiar with. Those are just our counting numbers. But when we're talking about our rationals, those are things like our fractions. Okay, so they're numbers that still, in a certain way, they make sense. Rational, it's rational. Now, a couple of things that you'll need to know. First thing is a prime number is basically any number only divisible by one in itself. And composite, the easiest way to write this is basically it's not a prime. Okay, so for example, prime numbers, some examples of prime numbers are 2, 3, that was a horrible 3, 3, 5, 7, 11. All these numbers can only be divided by 1 in itself to give no remainders. Okay, so a composite number is basically numbers that aren't a prime. So numbers like 4, 6, 8, 9, and so on. Now, keep in mind that here, 0 and 1 are special cases. Neither one of these are prime or composite, they're just special cases. Okay, so moving on. If I've got a question, it might say something like this: factor 210 into its prime factors. And so this is where we'd use something like a factor tree. So I can see here, 21 looks familiar to me. It's probably going to be 3 times 70. Because it's like 3 times 7, but an extra 10. And then 3 is a prime number, so I'm going to leave that as is. 7t, I can see can break up as 7 and 10. And then 10 will break up as 5 and 2. And 5 is a prime, 2 is a prime. Don't forget, 2 is the only prime number that's even. And that's it. So in this case here, 210 can be written as 2 times 3 times 5 times 7. That's broken up into its prime factors. Okay. And I think that is it. All right, moving on. Now, operations with fractions, we've done a little bit on this in our algebra topic. So when you have addition and subtraction, just remember you need to have the same denominator. Okay. For multiplication, what you do is cancel if possible, or simplify if possible, and then multiply across. And for division, keep, flip, change, and then you multiply. Okay, let me show you. So for this one here, if I've got something like this, I'm going to need a common denominator. Now I can see between 4 and 3, my lowest common multiple would be 12. So how many times will 4 go into 12? 3. 3 times 3 is 9. And then 1/3 would be the equivalent of 4/12. Okay, by doing the same thing, if I go times 4 here, I'm also going to go times 4 there. And so now I've got them in the same denominator. 9 plus 4 is 13 over 12. I can leave my answer just like that. Okay, if I'm multiplying, this is where you recognize all whole numbers are technically fractions. So if I'm just going to time straight across, 1 times 9 is 9, 2 times 1 is 2. That's it. And for this last one here, I've got 5 on 12, and this is a division. So I'm going to flip the second term. So keep the first term the same, flip the second term, change the division to a multiply. And then before I multiply these numbers, because they're pretty big, what I'm going to do is I'm going to simplify 12 and 36 as 1 and 3, because 12 is the common factor. I'm going to simplify 5 and 25, and then I'm going to multiply what's left. So 1 times 3 is 3. 1 times 5 is 5, and that's it. decimals and notation. So terminating decimals, I'll give you an example. Something like 0.12, or a recurring decimal means we'll have 0.12121212, blah, 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 blah. Okay, so terminating decimals, basically they stop, whereas recurring decimals recur or repeat. Now, both of these types of decimals, they're still rational, and we're going to need that for the next lesson. So just remember that both, if your decimal stops or if your decimal continues, but there's a pattern, these are considered as rational. Okay, now if I wanted to express 1/3 as a decimal, the way you do that is you can use your calculator. You can go 1 divided by 3, and that would be 0.333. And so you can write it as 0.3 and then just put a dot over the repeater. Okay. Last one is percentages. Percentages, they can be written as decimal or fraction. And so fractions, decimals, and percentages can be kind of interchangeable. So for a question like this, we've got 4/25 as a percentage and a decimal. You're expected to be able to do this without a calculator. So here, I know it's 4/25, but if I want to change it to a decimal or a fraction, the base number that works very well is, as a decimal, the number that works very well here is going to be 100. Now, if I times by 4 on the bottom, also times 4 on top, and so that'll be 16 on 100, and I can write that's 16%, or it's 0.16. Hopefully this is all revision for you. Now, these ones here, working with percentages, if I want to find certain percentages, here's how I would do it. I'd go, what's 10% of? So I'd go 10% times 150 in your calculator, and I know this is just going to be $15. Okay, if I want to increase $150 by 6%, the way that I would do it is I'd say $150, and then I'd times it by 1.06, or 106%. And that will give you some sort of answer. Don't have the calculator on me. Now, if I want to decrease, it's going to be a similar thing, but slightly different. I'm going to go 150, but if I decrease by 14%, theoretically, I'm only left with 86%. So if I multiply those two together, that should give my answer as well. And these ones you can use the calculator for. Okay, I think that brings us to the end of this lesson. Hope that helps, and I'll see you guys later. Bye-bye.